Hi students, this is Alex here. In this video, we are going to find the Fourier series for the given function f of x and we are going to deduce this relation. As a first part, I have to check whether the given function is odd or even. I take this first part of the function as g1 of x, which is minus k, and second part as g2 of x, which is plus k. I'm going to find what is g1 of minus x. Every x is replaced as minus x, but there is no x, so it is minus k itself. But this k can be replaced from here, that is nothing but g2 of x. So we get g1 of minus x equal to minus g2 of x. It means this function f of x is an odd function. So we found it is an odd function. When it is an odd function, we get a naught equal to 0 and an equal to 0. So it is sufficient to find only bn. Bn by formula, it is 1 by, or we take it as 2 by pi integral 0 to pi f of x into sin nx dx. Now 0 to pi, we have the function f of x as k. So this is 2 by pi integral 0 to pi k into sin nx dx. So this becomes 2 by pi, k is a constant taken out, and integration of sin is minus cos nx by n, and our limit is from 0 to pi. We are going to substitute the upper limit. So 2k by n is written as, by pi is written as it is, and even n can be taken outside, so n pi, and we have minus cos n pi, minus of minus plus cos n into 0. Now this becomes 2k by n pi, cos n pi, there is a minus sign outside, we keep that as minus 1, and cos n pi is minus 1 whole power n, and cos 0 is 1. Now finally we have this as 2k by n pi, and this is minus 1 whole power n plus 1, n plus 1 plus 1. So this is our bn. Now coming to the expansion, f of x equal to summation n equal to 1 to infinity bn sin nx alone we have, because a0 and an are 0. So summation n is equal to 1 to infinity, this is 2k by n pi into minus 1 whole power n plus 1, then plus 1, then sin nx. This is our f of x. Now we shall expand this. Before that, constants can be taken outside the summation. So 2k by pi is a constant that is taken out. Now we have summation and minus 1 whole power n plus 1, then plus 1, the whole thing by n into sin nx we have. Now we are going to expand this. So f of x is equal to 2k by pi. Now when n is 1, this total power becomes 2. Minus 1 whole square is plus 1, so 1 plus 1 is 2. So 2 by n into sin 1x. When n is 2, this becomes 2 plus 1, 3 odd power. Minus 1 power 3 is minus 1. So we have minus 1 plus 1 gets cancelled, and for n is 2, the value is 0. Now we are going to substitute 3 for n. So again it is 2 by 3 sin 3x. Again we substitute 4, it will become 0, because minus 1 whole power 4 plus 1 is 5. This is minus 1, already there is plus 1, so it becomes 0. Now I have to substitute 5. So 2 by 5 sin 5x and dot dot dot. This is how it goes. And f of x, by taking the 2 common throughout the term, so 4k by pi bracket open, we have sin, actually this is 1 because n is 1. So sin x plus 1 by 3 sin 3x plus 1 by 5 sin 5x plus dot dot dot. This is our f of x. Now let's take x as pi by 2. Actually, we got the Fourier series expansion. Now we have to deduce the relation given. They have given a series which is pi by 4 equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7. So for proving that, I am going to take x as pi by 2. Now this is f of pi by 2 equal to 4k by pi. Now sin pi by 2 plus 1 by 3 into sin 3 pi by 2 plus 1 by 5 into sin 5 pi by 2 plus dot dot dot. Now f of pi by 2, actually this is the place where pi by 2 lies in between. So the value of f of pi by 2 is k. So we take this as k. So k equal to 4k by pi. Sin pi by 2 is 1, sin 3 pi by 2 is minus 1, so minus 1 by 3, sin 5 by 2 is plus 1, so 1 by 5. So this is how the series goes, and we can cancel this k and k. This pi will come to the numerator, so pi, and this 4 will come to the denominator. So pi by 4 equal to 1 minus 1 by 3 plus 1 by 5. If you want next term, it is minus 1 by 7. Like that it keeps going. So we got this proof. Pi by 4 equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus dot dot dot. So we got the proof by taking x as pi by 2.